Okay. Hello everyone. Good afternoon. And hopefully you already scanned the QR code. Okay, maybe wait for a few minutes. Okay, 1 or 2 minutes, and we can start. Okay. Okay, so for today, I would like to start with our previous feedback question, and we can have more practice example for sketching curve. Maybe 1 or 2 more example. And after that, maybe we can move to the next section. Okay, let's start. Okay, let's start with a review for our feedback question. So we are given this graph, okay, and you can see from the information in the graph, in the picture, y equal, okay, y equal f prime. So this red curve here is first derivative, okay, first derivative. Okay, the question is asking the graph f prime is shown, what interval the function is concave upward. So it's wanted to find the interval for which the function will concave upwards. Okay. First, okay, what you need to remember is, okay, concave upward or concave downward. It depends on our y double prime. Okay. So y double prime, the second derivative, okay, for concave upwards, it should be positive. So I can write this. For concave downwards, it should be negative. Okay. Now, how to find the positive and negative from f prime? From the first derivative, of course, you can see the slope. Okay, the slope. Okay. So first, imagine. Let me just write from very beginning, from 0 here. Maybe the slope is here. Okay, slope is going down here. So the slope is going down from 0 to x equal 3. So this will be slope negative, right? Slope negative. And then from 3, okay, let me just write this 3. Okay, from 3, it's going up, going up, going up. So let's write this is a positive slope. Okay. And then at x equals 6 is undefined, and then it's going to start another positive. So it's positive, positive, positive. So upwards means we need to have the positive. So it will be from 3, okay, from 3. Let me write with different color. So from 3 to 6, okay, and then from 6 to, we don't know, let's just say we have infinite amount there. So that will be the slope that is positive, and that is precisely what this answer is. Okay. Okay. So you can see from the slope. Okay. If it is asking about the function increase or decrease, then we can see from the f prime, or maybe, okay. And we can look directly from the graph that is 0 to 2 is increasing, 2 and 4 decreasing, it's negative, right? It's positive. And 4 to 6 is increasing, it's positive. 6 to 8 is decreasing, and 8 to infinity is increasing, it's positive, right? Okay. Okay, so I think this kind of question, I think you should be able to tell, okay, how to find the um, when the function is increasing, decreasing, concavity, okay, upwards, downwards, okay, and when will be the critical numbers, okay, and also the inflection point. I hope you can get observation from this kind of question, okay. Okay, that's the first question. Okay, I hope it's clear. Okay, I hope it's clear. Okay, next question. The second question is this. Okay. And now this is graph is a y equal f of x. Okay. So this is just a regular function. It's just regular function. The graph is shown at which point that graph y prime positive and y double prime also positive. So both first derivative and second derivative positive. So how to look from this graph? If you want to look the first derivative, then you need to look the slope. Okay, you need to look slope. Maybe I can write the slope first. Okay, at a the slope is going down like that. Maybe I'm using different color. Maybe pink. So at a it's going down like that. The tangent. The slope at b is like that. Uh, Slope positive. So this is negative, positive. Okay, and this is positive. This probably 0, and this going to be negative. Okay. And for concavity, uh, my my preference, my suggestions, you can take the this kind of like a U shape, take arrow from downside to upside like this, and that means it's facing upwards, right? So that means it's concave upwards. I think it's easy to remember. It's facing upside like that. And then after, I think after this point, it will be facing down like that. Up until all the E, right? So when it's going to face upwards, we say this will be positive, or we can say this is concave upwards. This is concave downward. And we can see from here, this is positive, so it should be B. Point B is where the y prime, the first derivative positive, it has slope positive, and the concavity is going up, and it's also positive, right? Okay, so that the answer will be the point B. Okay, point B. Okay. Some of you answering C. Yeah, I think when you answer C, maybe you mix between the concave downward and upwards, okay? Because it seems it has a maximum, it's maybe up, going up, right? But my suggestions to make the definition is easy. Take the arrow and take the arrow here. Okay, so it's going to have, okay, it's going up and it's going down. Okay, okay. Okay, I think that's the number 2. Okay, number 3. Oh yeah, I already make this for you so that it will be easy. Oh, yes, yeah. So we have a function. This is the function x squared. Okay, x squared minus x minus ln x. And then the question is find the inflection point. Find the inflection point. So first, I directly write a derivative and second derivative. Okay, x squared becomes 2x minus 1. Okay, I think that's easy. And then second derivative, it becomes 2 minus 1 over x become plus 1 over x squared. Okay, to get the idea for second derivative equals 0, let me rewrite this in a rational form. 2x squared plus 1 over x squared. Okay. Now, okay, if we look here, this is always positive, right? It's always positive. Okay. So whenever you find any x that you put on, it will be always positive. So it doesn't seem the second derivative changing from negative to positive or from positive to negative. So for a reasonable explanations, that it will not have an inflection point. But you can check, okay? You can check first what kind of points that we have. Okay? Maybe we can start with the first derivative here. If we want to check, we want to check 2x minus 1 over x. Okay? So check the first derivative. Okay? So check here, make it in this form, and make it equal 0. Okay? And check whether there is some special point there. And I think for the domain, this x, it cannot be 0, right? It cannot be 0. And also, we can rewrite this form. And then, actually, we will have two kind of x, negative 1 over 2 and 1. But why I ignore this or skip this negative 1 over 2? Remember the domain at the very original function. Okay? So this is because if you look at here, we have ln, right? The original function have ln. So ln cannot be negative, right? Okay. So that's why this solution is not in domain. So our x is only 1. So it should be 0 and 1, and 0 probably has the asymptote, right? Because this form here, right? Yeah, because this form here is not equal 0. So to check whether the function is having negative and positive sign for increasing or decreasing, we can check several points. Okay, we can check several points. So we can check maybe 1 over 2, maybe check 1 over 2, check 1 over 2, check 2, okay. And of course, you can check negative number there because it's not in domain, right? And we know that it is only having a local minimum. And the graph, if you draw the graph and if you check with the graphing calculator, the graph will be looking like maybe like that. Okay, maybe like this. Okay, so it's actually like an asymptote. It's closer to 0. Okay, and that will be the graph. And you will see that from this graph, we can make sure that okay, there is no inflection point there. Okay, but actually, If you just ask whether it has inflection point or not, if you look at here, it's always positive. Okay? It's always concave upwards. Okay, so this means always concave upwards, and that's true from our graph here. Okay, concave upwards. Okay, I think most of you did a good job. Okay. Okay. Any questions from all this review from our last feedback? Okay, I think it's clear. Okay, I think it's clear. Okay. For online students, do you have any questions? I think no, right? Okay. Okay. I give the I think last Tuesday I'm giving you this question. Have you tried, or have you maybe tried to use uh, maybe a graphing calculator or maybe an app? If you want to download in your smartphone or in your tablet, you can check and draw this, and you will see it's a little bit interesting, the graph. And we can also do with a little bit calculus, but it's not really a nice number if you do the calculus part. But let me show you how it's done. Okay, first, if you look the function, if you look the function, we have 1 over x squared, and then we have negative 1 over x minus 1 squared. Okay? From the bottom part of the function, we see that x is not equal 0, right? It should not be equal 0 for the domain, and x also not equal 1, okay? Because it would be undefined if we are having 1 and 0. So we can start with the domain. We can start with the domain. So we can start with the domain. We can just write x is not 0 and x is not equal 1, and all x is all real number. That's still okay. And then find the intercept. Okay, find the intercept. There is no y-intercept, right? Because x is not equal 0, so we can just find the x-intercept. We can find the x-intercept by taking this function. Let me rewrite the function. Okay. And let me calculate this. Okay. And then we have this is 2x. And we need to equal this to 0. And we get 2x is equal 1. So x is half. Okay. So when x is half, f of x is 0. So f this is 0. So half and 0 will be our intercept. Okay. And at the third, we can have our asymptote. Okay, let's start with if we have limit and x approaching positive, negative, infinity. Okay. We can separate the limit. We have this limit, right? 1 over x minus 1. or we can rewrite this in expansion. Of course, from here, you know that if we calculate all limit here, it will be equal 0. So y equals 0 will be our horizontal asymptote. And then from vertical asymptote, from the function itself, we see that it doesn't have the x equals 0 and x equals 1, and probably that will be our asymptote. We can check with limit. Okay? We can check with limit. So first checking with 0, you can check from left, from right. And this will be resulting the infinite. And we know that this will be vertical asymptote. And checking the limit as x approaching 1 from left or from right. This will be resulting, okay, if you plug in 1, okay, if you plug in 1 to x here, it's 1 minus something, right? 1 putting here, it's infinite, right? It's negative, so it should be negative infinite, okay, right? So it's negative infinite here. And this will be our vertical asymptote. So x equals 0 and x equal 1. Okay, so domain, intercept, asymptote, the next will be the increasing, decreasing, and we can check with the first derivative. Okay, so we may need to derive the functions. Let me check the functions. Functions. Okay, let me write. Maybe I will move to the next slide. Okay, let me make it new paper. Okay, so let me write again. The function is 1 over x squared minus 1 over x minus 1 squared. Okay. And I prefer to have the function in this separate like this and then derive each part. Instead, making one and then do quotient rule, maybe it's take some a long calculation. So we can take the first derivative, which can check the 1 over x squared. It's become, it's, let me write here, so that you can take this. So it will be negative 2 x cubed, right? Okay. And the same way, for 1 over x minus 1 squared, we'll have exactly the same with different denominator. And because it's only x here, if you use the chain rule, it's just 1, right? So we can have this exactly similar, and then plus. Okay, negative 2, negative, it's become plus. X minus 1, and then cube. And then check, okay, check the f prime. we can check and make this make it into x cubed. And then checking with 0. And if we want to check with calculations, we can take this to x cubed minus 2. Okay, if we want to check the expansion, we need to do some cubic formula. We can check with the cubic formula, and then we can look at the calculation here. So this will be cancel this. So we will have 6x squared negative 6x plus 2. Okay, so if we want to make it equal 0, okay, we need to check. Okay. But first, we can check if you remember, check the determinant. This is 6, negative 4, and then 6, and then 2. So it will be this, right? So which means this is, we have no real solution, right? No real solution. So we will have an imaginary number for that case. So what does it mean? What's our conclusion here? If there is no real solution from this equation here, then what is our conclusion? Well, our conclusion for now is maybe there is no critical point, no critical number, okay? Because there is no f prime equals 0 that is in our real domain. Okay? So we can write, no critical point. But then how we can check our increasing and decreasing? We can check from the number that might be not in our domain, like 0 and 1. Okay, we can check that, and we can check when the first derivative positive or negative. Okay, we can check with line number. Checking with 0 and 1, and also they are our vertical asymptote, right? So if you imagine if this is asymptote here, okay, and then maybe we take some value, okay, we can take some value maybe from here, maybe -1 from the left. We put in here, we put in -1, -2 cube, it's still negative, negative is positive, -1, negative, it's negative, -8 plus 8, -1, -2, so it's still positive. So the up, it's positive. It's negative, negative, it's positive. So it's positive divided by positive, it's positive here. And then maybe checking, so checking -1, checking maybe half, okay, and checking maybe 2. If you want to check 2, you can check 2. It's -2, -2, 16 is positive. 2 positive, positive, it's positive here. If half here is negative, positive, negative, half, negative, negative, positive, half, I think this will be positive because it's bigger. It's only half, and then it's negative, so it should be negative, right? Okay. So I'm doing some just quick calculations. Okay, you can check if you want one by one. So this will be negative. So this will be going up, going down, going up. But remember, it seems that it will be maximum and minimum here. But we remember from our calculation in asymptote, 0 and 1 is asymptote. So probably it will be going like that, and it's and in the middle here may be going like that. Okay, but we are not sure the concavity. That we need to check. Okay, but at least we know it's increasing from here, increasing in the decreasing in the middle, and then increasing at after x equal 1, right? After x equal 1. Okay. Okay. Now seems a little bit complicated, but actually we can still do some calculations. We can still do some calculations. Okay. Now this is all f prime, right? After that we need to check the concavity, whether the function is like a U shape or the or opposite, like okay, like this. Okay. So we need to check concavity, whether the functions or the interval is concave upward, concave downwards. Okay. But let me give you a little bit break time for looking at this first. Okay. And maybe you need to take some time to check and maybe to look at the equation. Okay, by the way, the last part here, the bottom part here, this D is called determinant. This D is called determinant. We can know the functions having the solution if we check the determinant first. Okay, if it is having a positive here, so we will have usually we are use it for finding the roots in the quadratic functions, right? Remember you have the quadratic formula. Okay, this is inside the quadratic formula. Minus b plus minus this, and then divide by 2a, right? So if we check the determinant and this is resulting negative, which means we don't have real solution. Unless we are going to check the complex, okay, okay, the complex number. But we are stay away from complex number. This calculus, okay, this calculus. We stay away. All right, let's continue a little bit. Okay, let me go here. Let me write the f prime is -2 over x cubed plus 2 over x minus 1 cubed. Okay, so I will use this form to take the second derivative. If I'm going to use this one right here, you will be using the quotient rule, quotient rule like crazy, right? It's too much equations here, so I also stay away from this, and let's just use this one here. Okay, so let's use this, and we derive this function here. Derive f prime becomes f double prime, and it's become -3 -4, so it will have the -6, so it will be 6 divided by x with power of 4, right? and then it's plus, it's become negative, it's 6, and then this will be x minus 1 with power of 4. It's a bit. And now we can maybe rewrite this form to see our second derivative test. If you want to do some expansion for this, it will be 1, 4, 6, 4, 1, right? So it will be x with power of 4, and then plus 4x cubed minus 6x squared plus 4x minus 1. Okay. Is it correct? I think it's correct, right? Yeah, we can check this also from x minus 1 squared, x minus 1 squared. Okay. You can check this if you want to check one by one, and I think it will be resulting this. So we can write, if you want to write here, 6 x minus 1 it's it has some advanced form here, but I think we still can do some calculations. Okay, so if we look here, this is for the x minus 1 with power of 4. Okay, I think we will have 6x power of 4 and 6x power of 4. We can cancel, and we will have this 4. Okay, so we can write this. Let me write in the bottom here. So this will be 6 and then 4x cubed. Okay, now to check the whether this has the inflection point, then we need to check this equation equal 0. Okay, to be equal 0. Let's check equal 0. Okay. The bottom, the x with power of 4, x minus 1 power of 4 is always positive, right? Always positive. Any x you put here, this is an even number, right? So it's always positive. So whatever x is always positive. So always positive. So we will know from this numerator. Okay, so we can check the cubic formula. So we can check the cubic formula. So we can check with, let me write as P 4x cubed, 6x squared plus 4x minus 1. Okay, how to find the roots from this cubic? Okay. Any idea how? There is one. It's like a quadratic formula. We call the cubic formula, but I think it's too complicated to write and to calculate. So I will give you a tips, okay, on how to solve this cubic. Okay. Okay. Look at this. This is 1 at the very end, right? The constant. The front, in the front you see 4. Okay. So to find first, if we are having this little p, little q, we will have possible. It's called possible rational zeros or rational roots. Okay. This is p over q. What is p? P is a factor of the last constant at the end. Okay. So this is a factor of 1. And q will be factor of 4. What is a factor? A factor is, for example, okay, factor of uh, factor of 8. Factor of 8 is 1 or plus minus 1, plus minus 2, plus minus 4, and plus minus 8. So any number that when you multiply these two, 1 with 8 it's become 8, or negative 1 and negative 8 become 8. 2 and 4 become 8, negative 2, negative 4, it's become 8. Okay, that's the factor. Okay, if you remember, I think it's elementary school, right? Common number or factors. Okay, I think it's in the elementary. So if you have factor of 1, then 1 is only having plus minus 1, right? Divide by 4. 4 will be having 1, 2, and 4. Okay, this means we can have zeros or the roots, and roots or zeros, that is plus minus 1, okay, plus minus 1, plus minus 1 over 2, okay, and plus minus 1 over 4. Okay, so we have 3 possible rational. Okay. And then what we are going to do from here, we can check one by one. But I think we have to check 6 numbers, right? Plus 1, negative 1, plus 1 over 2, negative 1 over 2, plus 1 over 4, negative 1 over 4. Right? To narrow our number, we can look at the functions back to these polynomials here. We can look at, this is called the Descartes rule. This is called Descartes rule. This is positive, negative, positive, negative, right? Whenever it changes, we count that as a variation change. So plus to negative, we write there is 1 change. From negative to positive, there is also change. This is 2. And from positive to negative, it's also change, right? So we'll have 1, 2, 3, 3 variation of change. That means, okay, we will have 3 positive roots or 1 positive root. Why we need to write 3 and then 1? Because the rule for this method is saying that, okay, we will have 3 from this change, or we need to minus with 2. We will have 1 positive root. Okay. Okay. And then how to find the negative root? We put negative here and check the other functions. Okay. So we will check. Okay, we will check here. So we will check the p negative x. Okay. So p negative x will be, so let me write, or maybe write the original one here. Yeah, it's not in the calculus, but this is just to let you know you can use this method. So this will be 4x cubed, and this will be still 6, and this will be 4x, and negative 1. If you see all negative like this one, there is no change in the signs, right? We can say that there will be no negative roots. So we can only focus on, from our possible roots here, we can just checking the positive one, because that will be our root. 4 definitely that will be our root. Okay? Trust me. So we can skip the negative, negative, negative. We skip them. Okay? So we check 1, half, and 1/4. And how to check that root? We can use our let me write in the new page. Okay, let me write in the new page. Okay, let me go first to the next page. And if you need to go to the previous slides, I will let you know. Okay. Let me write first. So possible root will be, we can check half, 1/4, and 1. Okay. So we can check the positive. We can check by checking like this. One by one, we are going to check. But if it is still, maybe you still feel too much calculations, maybe we can say we can write the divisions from polynomials long divisions. So we can write 4, -6, 4, and -1. We can start with 1. Okay, check 1. I hope you remember this method. Okay, we don't have the answer here because it's resulting a number, right? This we call the remainder, right? It's not divided completely. Okay. Let's check the other one. Let's check the half. Okay, we got 0 now. Okay. And if this is 0, then it means it's completely divided. And x equal half is our roots or zeros. Okay. If you check 1/4, I believe it will be also have remainder. So if we look back here, okay, let me make this for this one. We have 3 positive roots or 1. If we check the possibility from our zeros here, we only have 1 positive. Okay, 1 positive. And then we check the negative roots. We don't have negative roots. So where are the other 2? It will be our imaginary roots. Okay. So maybe let's copy this first to give you a good way to see. Okay, if you see here, okay, from this, we can take the so positive roots or positive zeros, negative zeros, imaginary number, and total. So at the beginning, we say that we can have 3 positive 0 or 1 positive 0. And there will be no negative 0, no negative 0. And the total, because it's cubic, the total root should be 3. Okay? Right? It's x cubed. The x solution will be 3 number. So if we have 3 positive zeros, 0 negative zeros, then there is no imaginary number also. So we can write this as 0. And if you have 1 positive 0, but the total is 3, then the other 2 must be in the imaginary number. Okay. So this is sometimes if you try to tackle any polynomials, maybe with power of 4, 5, 6, the first thing you need to do, you can maybe you can reduce the the degree. Okay? How to reduce? You can check with some factors here and check with the synthetic division. This is called the synthetic division here. This is actually the same way you divide the p. So you can also look at this as 4x cubed negative x squared plus 4x negative 1 divided by x minus 1, this one. Or this one here is 4x cubed negative x squared plus 4x negative 1. This is divided by x minus half. And you will get here. And the result here, if this is 0, then this one here is this, okay, the quotient, right? And if this is having 1 as a reminder, this result should be having 1 here. Yeah, I think in mathematics, it's in the polynomial chapter. Okay, if you check the polynomial, this is called the polynomial long division. So you have division, okay? And this is actually simplification of this method, okay? The synthetic division. So this is 4. 4 is means the x cubed, negative 6 is x squared here. 4 will be the x, and the constant will be here. Okay? And the way you are taking this is the synthetic is this is our possible root, right? A possible root or possible zeros, 1 over 2. Take this 4 going down here, and 4 multiply with half with this 2 result, and then add negative 6 to 2 is negative 4, and doing same way until you get 0. When you get 0, that means this half is the solution, is our root. So okay, that's our zeros. Okay. 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 Hopefully this helped whenever you find a polynomial with a high degree, okay, higher degree. Okay. That means if we get this x equal half as our root, that means this is our inflection point. Okay. So this is a little bit a sidetrack. Okay, not really a calculus, but I think it's helpful if you later facing maybe something like cubic or maybe 4-degree. Maybe you can think and check the first. You can check the possible roots. Okay, and if the polynomial provides with the really nice number, you will get really nice results. Really nice results. But this one, I think, not really nice because we have the imaginary roots or imaginary number in our zeros. Okay, so that's the a little bit of additional things about the polynomials. Okay, and this is called this one here. This method is called Descartes rule. Okay. Okay. I think this is helpful. Okay? You think this is helpful? And it's not in your textbook. It's not in your calculus textbook. If you read the calculus, no, this is not in that book. This is in the general mathematics, okay, about polynomial. Okay. Any questions? Any questions? Any questions? Okay, if you still feel you need more explanation about this rule, I will make some additional video for you. Okay? At least from here, because this is actually not in our chapter. This is not in our chapter, but I'm writing this method to help you if you have this kind of difficulty finding the higher degree polynomial. Okay, okay, I will have another explanation about this method. Okay, maybe I will make another in a video and I will upload to the YouTube channel. And yeah, we will continue from here. Yeah, we will continue from here. Uh, let's say we have this, so we already have f prime, and then we already have our inflection point here. Okay, uh, we can check. Okay, we can check our g prime, g double prime, or f double prime. Sorry. So check concavity. So if you feel confused about this method, you can skip that. For now, I will explain more in other videos. Okay, because I cannot explain all in today's class. Okay, so we can check the derivative, second derivative test. So we can check this x equal the inflection point. And we may check how it's going, and we may also write the asymptote 0 and 1 to see what it actually looks like. Okay, so we will have a line here that is crossing 0 and 1. So we may check. Uh, let me write the 6 for x cubed minus 6x squared plus 4x minus 1. And then x with power of 4, x minus 1, power of 4. So this is always positive. So we only have it. We only need to check the numerator. So we may start with -1. Start with -1 is -4, -6, -4, -1. It's all negative. Will be negative. Or maybe if we check the, let me write here. If we check the before we form, I think maybe it's better. Eh, wait, wrong. Okay, if we check here, I think it's better, right? It's easier. It's positive. It's positive. So 6 minus 6 over -2 to 2, 4 to 16. It's positive, right? Yeah, it should be positive. Should be positive. Should be positive. So this should be positive. And maybe this we can check 1 over 4. Check 1 over 4. this will be resulting with should be positive, right? Positive, positive, and half to 1. We can take 2/3. You can check 2/3 probably, and also checking x equal 2. Checking x equal 2, 16 is negative here. So this will be negative, negative, so positive, positive, negative, negative. Okay. Okay, let's check the graph. Okay, let's try to graph this. So let me write the f prime. We got the 0 and 1. This is positive, negative, positive. This is the VA, the vertical asymptote. We get the second derivative. This is also VA. This is positive, positive, negative, negative. Okay, let's try to draw. And let's say we have 1 is maybe here. Okay, 1. And let's draw the line for the asymptote line. Okay, now this is 0. This is 0. This is half. Okay, from negative infinity to 0, it should have a positive slope. Okay, so we can start with drawing the slope like that, positive slope, right? Positive slope. So it can be like this or this, right? But the positive slope from negative infinity to 0, positive, and the concavity is also positive. So probably it will be this, right? Because it means it's concave upwards. So we can write this is concave upwards. So maybe this will be like this. Okay. Because the y-axis is also, so this is the VA, VA, and also this is HA, the horizontal asymptote. Okay. So the curve should be closer to asymptote for vertical and then also for the horizontal one. Okay. And from 0 to maybe half here, it should be still have concave upwards. But if we look at from 0 to 1 here, it's negative. So it should be decrease. Okay. So we can draw the decrease one first. So the decrease is maybe the slope like that. Okay, let me just draw that. But at the very middle, this half here, there will be change in the upwards and becomes downwards, right? The concavity change. Okay. So from here, we can take it's going down like this, and eventually at this inflection point, it will be changed. So it's still going down. Maybe like that until the x equal 1 over 2. Let me erase this first. Maybe right here. And then after that, we will have concave downwards. Okay? We will have concave downwards. Maybe we look at until 1 first. Okay, until 1. So concave downwards. So we will have down like that. Let me make clearly. Okay, probably like that. Okay, and then after 1, the slope is going up. The slope is going up, but the concave downwards. So we will need to write from here, from down, from the below. We need to write from below. We'll write from below. Let me draw here. And it will going up. And it will be getting closer to this horizontal asymptote. Okay. So this is also, if we look at this, it's the slope is positive, right? The slope is positive, it's increasing. Positive slope is the middle is negative slope. Okay, and I think for all the essentials, the important inflection point, increasing, decreasing, the vertical asymptote, horizontal asymptote, I think we are make our graph clearly. Okay, so the graph not if you draw the graph on your own, it doesn't need to be really smooth. It's good if you draw really good, smooth, but the important thing is you need to mention, like, if there is asymptote, then you need to draw closer to that asymptote. Okay, and maybe mention that this is the horizontal asymptote, and maybe this is the vertical asymptote. Maybe just HA, VA, VA. I think that's enough. And then maybe mention this is inflection point. Maybe I will write inflection point here. And maybe write this is the inflection point, IP, like that. And you see that there is no critical number. So no maximum, no minimum. So it's just going up, and then we don't really see any maximum number here. And the minimum number here is asymptote, right? Yeah, and for our case in this class, this question is actually a little bit complicated. And I said this question from I think the question asking to draw in graphing calculator, but actually we can still do it. Okay? We can still actually do it. Okay. Of course, in exam, if this happens, I will not let you take this kind of question. This is just for exercise, okay, for our practice. Okay. Any questions? Any questions? Do you want to take some notes from the previous slides or no? Any question from the online students? Do you want to see the process from the beginning? From here? Yeah, this is the beginning. Okay. The beginning, find domain, find intercept asymptote. I think this is, clear. Not really that complicated. But when we reach the first derivative, we have difficulty because we find that there is no critical point. And I think this is to show you that not always the critical point is not always shows up. Okay, so sometimes the function they don't have the critical point, and then we check the second derivative. We encounter the cubic. We encounter this x cube. Okay, we encounter this x cube, and I give you this method here to find possibility of how to find the solutions, okay, for the polynomials. I will let you know whenever I put additional video. I think this week I will put, or maybe next week. And then this is how the method is going. And basically, this is basically a simply checking try and error, checking half, checking 1/4, checking one, but with some nice step procedure. So you are not really try from random number. You want to make narrow, and then you can just check with this three number here, and you get this 1/2. Oh, we got at least one root. Okay, we got at least one root. And when we got one root, then we know the other one here. And actually, you can use this in quadratic. This is 4x squared, negative 4x plus 2. You can check the determinant, and I think the determinant will be negative. That's why it's imaginary. It's a complex. Okay. So from there, we can just make that, okay, our roots here, x equal half, there will be our inflection point. Okay. If there is another x, there will be three inflection points, but we will have only one here. Okay. And when we draw, okay, we check the concavity, and then we draw the graph. We see that, okay, it's true that it's only having this change here, the inflection point, only one point there. Okay, I think we can have another practice. Okay, I think I can give you another questions for to solve. Okay, let me check the questions first. Okay, we can start with. Let me give you the new slides. I think we can start with sketch the curve. Okay, now I'm trying to have another variations. Now we can look at we have the exponent e. Sketch the curve. Okay. Okay, let me give you two curves. Let's go sketch the curve. First is this. Second is, I think, the one that is more easier. I think it's much easier than the what we did previously. Okay. It's much easier. And sketch the curve. And if you want, you can check the curve. You can open the graphing app, any app you have, and check how the graphs looks like. Okay, and you can compare your result with your app graphs. So if you have any questions from the beginning of the course, just let me know. Yeah. Yeah, you need to maybe see this, right? Okay. Wow, really small. Okay. Am I too fast or no? My speech is too fast. The explanation too fast or no? Too fast? Too fast? Okay. Okay. Is my explanation too fast? No? Okay. So first, in every sketch curve, first three first things you can do: domain, intercept, and asymptote. Okay? And if you see any symmetry, you can also think about the symmetry, even and odd function. Okay? But first, maybe finding the domain. Okay, from here, domain. I think there is not a problem for domain, right? Because any x can put here, right? Any 0, 1, 2, you can put here. So I think domain should be okay. And maybe intercept. Okay, intercept. Check when x equals 0 and check when y equals 0. Okay. And I think for the first one, only y intercept, right? Only y intercept. Okay, for the online students, you can also check the curve. Okay. So domain for this is all real number, right? And then intercept is 1y equal 1 over 1 plus e0. So this will be 1 half. So at 0 half, this will be our intercept. And then I think no symmetry, right? If you check the This is we cannot say and conclude anything from this, and we can just conclude that there is no symmetry. And then we can check the asymptote. First, we can check as limit approaching positive from the 1 over 1 plus e negative x. And this will be resulting 1, 1 plus 0, this is 1. So y equal 1 will be horizontal asymptote. And but remember, okay, this is we need also to be careful. You need to be careful here. When you approach x to the negative, you need to be careful this. This is actually 0. Okay, how we can make that 0? We can look here. If we have limit as x approaching infinity of the e to the negative x like that. Okay, remember, okay, if you have e to the x, you can remember the graph. This is e with power of x, right? Please looks like that. If you have the e with negative x, then it will be, oh, sorry. Okay, yeah, it's around, probably looks like that. Okay, this is e with power negative x. So you will see when x is approaching negative infinity, when x is going here, it's going infinity, right? It's going infinity. But when it's going to infinite, it's going 0, right? So that's why this one here, when it's going infinity, it's going 0. But when it's going to negative infinity, it's going large and large and large, right? Okay, so we can write here that this is infinity, okay? And in this one here, 1 divided by infinity, something big, it's 0, okay? So that's why it's 0 here. And also you can think from this is negative, okay? E with something negative here, and then you have another negative, big negative. It maybe becomes positive, the signs become positive. But it will be something that big, right? E with something exponent big, so it's become really big. It's also, we can logically say that, okay, it's 0. But if you want to prove, like in the graph, you can check with the graph, okay, with E. I think E with power of x is a graph that you should probably familiar, okay, for e to the x. Okay. So you can check with at least two methods. Okay. And then another asymptote we can check is our, if there any uh, vertical asymptote. And I think no, right? Because based on our domain, there is actually all real numbers. So we don't have any possible for vertical asymptote. So this also y equals 0 is our horizontal asymptote. Okay. So the graph will have two asymptotes, and your graph will be in between this asymptote. And check the first derivative. This will be having 1 plus e. So it will be minus one plus e negative x, and then this will be a negative e negative x, right? So we can write this e to the negative x over 1 plus e negative x squared. Okay. Okay. When we look at this f prime, this the first derivative. Okay, so look here. It's e negative x, 1 plus e with power negative x, and then squared. So with this squared here, it's become clear that any possible x we move here is always positive, and this also always positive, right? Check 1 is 1 over e. It's still positive. Check negative 1 is also positive. Check 2, check 3, all x is positive. So this whole thing here is positive. So f prime is always increasing. Get it? Okay. So this is always positive. Let me write here. This is always positive. So we can say that the f prime or y prime, is it y or f? Let me just f. Let me write f prime of x is always positive. So f is always increasing. And this is impossible, right? If you want to find the critical point or extreme value. So no critical point. Right? Okay. Okay, next is the second derivative. Second derivative we can check from, I think we can just do quotient rule, not too complicated. Minus e negative x, and then 2 negative 2e negative x. Okay. Let me write this as positive and then change this. Okay, so this is the second derivative. So if we want to check the inflection point, I think we can try to check this. This one is impossible. So the other one, I think it's possible. So e with power negative x, it should be equal 1. So x should be 0, right? X should be 0. And probably this will be our inflection point. And we can check. We'll be checking right here. This 0 here, check. Checking x is negative. So if x is negative, then all will be positive, right? All will be positive. If x is negative, then will be, if this is negative 1, it's just plus 1, right? Plus 1, plus 1. So it's all positive, right? All positive. The key for this is, I think, here. It's here. Okay. If it is e negative 1, it will be 1 over e. 1 over e negative 1 is negative, right? So negative, positive, positive is negative. But if this is negative, this will be positive, right? So this will be positive. It will be concave upwards like that. And if this is positive, then this will be 1 over e, and this part will be negative, right? So this will be negative here, right? So this will be negative. So this will be concave downwards. Okay, I think we may have, I think, a simple curve. It's always increasing, but at x equals 0, it has inflection point, so it's going to be here and then going there. Okay. So probably it will be, if I draw here, I think I can just draw here. It has, let's say, the asymptote here. It's y equal 1 and y equals 0 here. And we have half as our inflection point there. Let me just put some marks there. So we may have like that and like that. Okay. So this will be concave upwards, and this will be concave downwards. And this will be the inflection point here. And this will be horizontal asymptote, horizontal asymptote. Okay. Okay. Any questions? Any questions? Okay. Any questions from the online students? Okay. Any questions? Any questions? I think uh, the key on how to maybe looking at uh, the the derivative test, the second derivative test is by trying some more examples, I think. And I think I can give you to like maybe practice, and then you can check at your home, and maybe giving you more additional videos, and maybe three or maybe four example in other videos, and then yeah, I think you can try that as well. Okay. Okay. Any questions? Any questions? Do you think it's difficult or no? Do you think it's difficult? Difficult? Difficult. Okay. Okay. Which part do you think the difficulty is? Which part? The derivative part, or which? Oh, okay. Let me show you. Yeah. Here. Okay. So from this, okay, to this, the second derivative, this is actually we are going to use the f g, for example, and this is basically uh, we are using the quotient rule. So this is f prime g minus g prime f. Okay. That is precisely what I'm doing here. So first, f prime, we have e with negative x, right? We derive, it's become negative e negative x, right? This is f prime here. Okay. This is f prime. And then multiply with this g, this one, right? And minus, I write the f first, this e negative x, and then this is the g prime. So let me write here, this is f. So this is g, this is f, this is g prime. So f is just minus e, directly e negative x. And then g prime is from this part here, g, derive. If you want to derive this, 2 going to the front, right? And this is, we write this, multiply with the chain rule. This part derived, negative e negative x. That's why I have negative e negative x 2, and then this. Okay? And then we simplify, take out e and take out this, put here, and we only have 1 plus e negative x here. Okay? And the other one is just negative 2e negative x, right? Because this is already taken out here. Why I need to take this out? Because I think I can divide by this, right? So that's why at the end, you can divide this, cancel, and then this 4 becomes 3, and we can calculate this, negative 2 plus this become negative e. And then this is actually, it's up to you. You want to write negative like this or positive, and then switch this, because I don't like having negative in the front, so I switch to positive and then make it this. It's the same thing here, okay, same thing. And that's why the answer is the second derivative is this. So I think the product rule, quotient rule in this kind of questions is probably you need more practice to familiar, because we will use that formula often. Oftenly we will use that. Okay. Okay. Any other questions? Okay. Do you get it for the quotient rule? Okay. Okay. So yeah. Okay. Any other questions? Online students maybe have a question or no? Okay. And I think you can try this. Okay, it's not too difficult. This one here, you can try. You can try. Maybe you can try to find the if you want to derive first. I think the derivative is not really complicated, right? 1 over x is like x with power -1. You can derive. It's also same. You can check the first derivative, check second derivative, check the domain. I think domain will be clear. X is not equal 0. So probably that will be our vertical asymptote. We can check with limits for the x equal 0. So we can check x approaching 0 from left, from right, check whether it is infinity or negative infinity, and then check, maybe checking the limit x approaching negative infinity to positive infinity. Check that limit also, whether it has the horizontal asymptote or no, and then check the first derivative test, increasing, decreasing, which intervals increasing and decreasing. Check the concavity, the second derivative. Okay, second derivative. You have first derivative and then second derivative. And I think to derive first and second, you can just make it separate first. Okay, it's better. Okay, it's better, right? And then check the concavity, and then you can check the inflection point and draw the graph. Okay. And I think the graph will be looks like this. The graph will be looks like this. Yeah, yeah, more or less it should be looking like this. You can check with the your graphing calculator. Okay? If you, I think I'm not sure. You can check in your smartphone if there's an app. Look at the App Store or the Google Play if you're using Android. You can check the Desmos, the app. I think Desmos have, GeoGebra also have. So sometimes it's useful to check with the app here. And I will give you maybe a few questions to check as your, yeah, maybe assignment. Okay, but I think it's a few questions only. Okay, if there is no questions, let's move to our feedback time for today. Okay, any questions? Maybe anything to discuss with? Okay, do you think I'm too fast today? Too fast or no? It's okay. It's okay. 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 Maybe if you need like review like that, like I can like make the previously and then maybe explain the quotient rule that you maybe not really look at, right? Okay. Okay. And also, if you feel you need like maybe you need more discussion and you feel not confident to say, you can email me and then I will have, okay, I will reply. Okay. Okay, let's move to the feedback time. Also, if you have any maybe problem with some, maybe sometimes you need to think the keywords in Chinese, right? You can make sure with your TA, okay? With your TA. Okay? Okay. 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 Yeah, it's the first problem that we solved today, the one that I gave you last Tuesday. That is, yeah, it's difficult. It's difficult. Okay. Let me go through. Let's wait for a moment. I have three questions, but I think it's actually review from last uh, meeting. So you can start three, two, one. Okay. Read the questions carefully. Okay. Similar questions like last time. Just checking, and now the timer is quicker. I hope it doesn't mind. I just want to check how well you're going to solve this problem. Okay, 5, 4, 3, 2, 1. Okay. Oh, okay. Okay, careful, careful. Okay. Sorry if it's the timer now is a little bit fast because I believe you should be more familiar. Okay. Okay. Okay, never gonna. Okay, I think give you up, right? Okay. Okay. Three, two, one. Okay, let's check and try. Okay, just true or false. Okay, true or false. Again, it's short time, but I hope you get correct answer. Okay. Okay, 15. This is to check whether you remember or not. Okay. Three, two, one. Okay. Ah. Okay. Don't worry. Okay. That's okay. It's false. It's false. Okay. Okay. Get ready for the last question. Last question. Three, two, one. It's a little bit long. So yeah, 2 minutes, I think enough. So you need to find A and B, and this 1.3 is the point of inflection. Okay. So now it's a little bit different. Okay, I hope you get it. You need to check the derivative and check with that point. I hope it's enough the time, but I think should be a little bit more. But I just want to check whether you can do this kind of question or no. But I believe is that if the time is 5 or 10 minutes, I think you should be able to do it. Right? This one. I just want to check if this is 2 minutes. Okay. Okay. Good. I think most of you did a good job. Okay. Will be okay. 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 So congratulations. Congratulations. Are you not in here, right? Not here. The students. I think it's online. Okay. Okay. So that's it for today's class. I will give you some practice for this chapter. And if you haven't checked the quiz, please check the quiz. Tomorrow will be the deadline. So yeah. Okay. Also for the online students, thank you for coming. Uh, and hopefully for the international students, we can hopefully meet you very soon. Okay. So see you later. See you next week. Okay. Yeah. You're welcome, Rion.